Hi, everyone. Welcome to Building One Canadian Economy, and thank you for joining us today. My name is Sarah Snowdon. I'm the Senior Comms Lead with the Pembina Institute's Buildings team, and I'm joining you today from the unceded territory of the Algonquin and Anishinaabe Nation. For countless generations, the Algonquin people have lived, cared for, and gathered on this land, which includes what we now call Ottawa. We honor their enduring presence, knowledge, and stewardship of these lands and waters, and commit ourselves to learning and acting in ways that support Indigenous sovereignty and reconciliation. This webinar will be recorded. The presentation will be about a half an hour with another half an hour question period at the end. If you have any questions for the speakers, please drop them in the Q&A section. And tech questions can be dropped into the chat. So the Pembina Institute is a national clean energy think tank that works to advance a prosperous clean energy future for Canada through credible policy solutions that support communities, the economy, and a safe climate. Introba is a global engineering and consultancy firm specializing in building decarbonization and lower impact design solutions. So I'd like to introduce our speakers for today. Ceileigh McAllister is an analyst with the Pembina Institute. Her work focuses on building decarbonization with files spanning Pembina's Reframed initiative, concrete decarbonization, and the role of buildings in demand-side management. Jeremy Field is an associate on the sustainability team at Introba, based in Vancouver, BC, with a background in energy modeling. He has led the assessment of material life cycle impacts for over 100 buildings across Canada. So with that, I'll hand this over to you, Jeremy. Thanks.
Thanks, Sarah. So why are we talking about this? As 2026 unfolds, Canada is working to secure our future by investing in ourselves through massive infrastructure projects and setting ambitions to build at unheard of scales in a way that will reshape how our cities and overall economy works. However, the design choices made today lock in costs and shape our competitiveness for decades. What materials are used, how and where they're made, those things matter in the long term. Are they durable? Are they made in Canada? Using raw materials from Canadian sources, using efficient techniques, and using technologies thought of by Canadians. Ideally, yes, all those things have been considered. As one of the most critical materials to modern life is concrete, and one of the most critical materials to modern life is concrete. It's the most used building material globally, forming the literal foundations of the cities we live, work, and play within. We focused on concrete also because of the essential role it plays for the Canadian economy. From buildings to roads and bridges to transit, concrete is an essential part of all types of nation-building projects and infrastructure, especially if we want that infrastructure to last long enough to serve generations of future Canadians. So the concrete industry itself contributes around $76 billion annually to Canada's economy. It supports over 166,000 jobs, as it takes a lot of people to quarry enough limestone, turn it into cement, blend that cement into finished concrete, and deliver enough of it to meet the demands of thousands of active construction sites across the country, some of which are almost certainly near you, no matter where in the country you're joining from. And while what shows up likely came from your local concrete plant only a couple hours away, cement is more commonly shipped longer distances or across provincial borders. The largest facilities in this supply chain within the country are our cement plants. There's only 14 nationwide, and they're the size of entire neighborhoods. And speaking of cement, concrete is a carbon-intensive material, mostly because of the cement required. Cement production is responsible for around 7% of global CO2 emissions and 1.5% of Canadian emissions. As we see on the slide, cement comprises just a small share of concrete by volume, but is responsible for most of concrete's emissions, mainly for two reasons. First, producing it conventionally requires extremely high temperatures, which requires a lot of fuel. Second, CO2, carbon dioxide, is released as a natural byproduct of the chemical reaction that happens when limestone is heated. Everything else that is needed to produce concrete is a relatively small fraction of the total climate impact. And why do we need cement? Well, if making concrete is just like baking a cake, you can think of the cement like the baking powder. It's not the ingredient we use the most of, but it's arguably the key ingredient, as without it, we just have a bunch of wet rocks and sand. The cement is what holds it all together and what makes it into what we recognize as concrete. Fortunately, Canada's cement and concrete sector is an active partner in working towards net zero. And alongside the federal government, the Cement Association of Canada published the Concrete Zero Action Plan. Today, lower carbon materials like Portland limestone cement are already ubiquitous in some regions, like Metro Vancouver, while the industry continues to research and deploy technologies that will enable even deeper reductions in concrete's embodied carbon. The National Research Council put out a great white paper on this last summer, which we distilled into three overall pathways. One, decarbonize conventional methods of making cement. This can involve things like fuel switching. Second, investing in SCMs, which are supplementary cementitious materials. This includes stretching sources of conventional SCMs like slag or fly ash, scaling alternative SCMs such as calcined clays or ground glass, and exploring emerging materials such as geopolymers, magnesium oxide binders, or calcium silicates. And third, maximize the carbon capture and storage potential of concrete. And this is in two subways. First, prevent the gases produced while making cement from ever making it into the atmosphere. This is feasible thanks to the highly concentrated nature of emissions coming out of the smokestack of cement plants. Second, replace gravel or sand, which make up the bulk of concrete by mass, with natural or synthetic materials that pull carbon dioxide out of the air in their creation. It's not possible to do at scale today, but by 2030, I personally believe we will begin to see not just zero carbon concretes, but carbon negative concretes hit the market. And when that does, the growth of our cities begins to heal, not hurt our climate. Now, the maturity, availability, and cost effectiveness of the practices and technologies within these pathways vary across provinces. Material supply chains, geology, regulatory environments, and industrial capacity all shape which approaches can scale most efficiently in a given region. Because of these differences, Canada's transition to lower carbon concrete must remain technology agnostic. Flexible, performance-based standards and coordinated procurement can support regional choice, reduce project costs, and encourage ongoing innovation. Ceileigh.
Awesome. Thanks, Jeremy. So, as we just heard, lower carbon concrete is not a distant aspiration, but it's a present day opportunity. Canada's cement and concrete sector is already leading the transition to net zero through research and development across the three pathways that Jeremy just described, while also exploring emerging opportunities for cement and concrete decarbonization in other areas. Sustaining this momentum will be critical in advancing climate competitiveness on the global marketplace, as well as unlocking deeper emissions reductions over time. Today, the most considerable constraint on these innovations are demand-side barriers. To support Canada's concrete industry, it is essential that governments enable a market to unlock this Canadian innovation. To lift these barriers, our research revealed 4 priority actions for government. Number 1, modernize codes, standards, and specifications. We must shift from prescriptive to performance-based requirements that align across jurisdictions. Number 2, leverage public procurement. Provinces should voluntarily adopt the federal standard on embodied carbon in construction for provincial procurement in order to send a technology-agnostic demand signal. Number 3, align private sector procurement. Government can reduce cost and risk for the adoption of lower carbon concrete through incentives to unlock market transformation. And number 4, strengthen workforce readiness. We must consolidate guidance, expand training, and develop a lower carbon concrete toolkit for workers across the construction value chain. I'll now pass it over to Jeremy to discuss our first recommendation.
Thanks, Ceileigh. So that first recommendation, that provinces must modernize codes, standards, and specifications through a harmonized performance-based framework to enable technology-agnostic approaches to infrastructure. This will create a consistent framework across jurisdictions to unlock Canadian innovation and lift barriers to interprovincial trade. So, making concrete releases gases into the atmosphere that have a warming impact, and the vast majority is emitted before it ever shows up at the construction site. Meaning that if we want to have a chance at reducing the impact of our major projects, we've got to think about it before it's been ordered, when the engineers and builders are working off blueprints and negotiating material specifications. And as they are today, codes, standards, and specifications are an active barrier blocking us from adopting innovative low carbon solutions. Concrete use in Canada is governed through a combination of building codes, technical standards, and procurement specifications that vary across infrastructure types and jurisdictions. But what's similar is they set boundaries the engineers and builders must stay within. For buildings, each province adopts its own building codes, but they're based on the National Building Code of Canada and reference CSA standards. And so things are decently aligned across Canada. For horizontal infrastructure, though, such as highways, bridges, water and wastewater systems, and transit networks, things are different. Requirements are set by public project owners through procurement documents, leading to greater variation across Canada and without even consistent logic in how it's organized. Some of these are quite prescriptive, dictating which materials can be used and how they must be incorporated. We dissected two examples from Ontario and Alberta in Appendix B of the report released in December, flagging how each makes some lower carbon solutions dead on arrival. And then for fragmentation, so standards and specifications can vary by project type, by province, and sometimes between municipalities. This inconsistency about how, when, and where materials can be used creates uncertainty for engineers and architects working across multiple jurisdictions or project types, and requires manufacturers to redesign, retest, or recertify concrete mixes for different jurisdictions, increasing administrative burdens and limiting economies of scale. These factors present barriers to interprovincial trade, add red tape, and drive up costs. What we heard from our engagement with industry was that many proven options exist to lower the impact of concrete today. As mentioned, some are common in some types of construction or in some regions, while being disallowed in others. Even when solutions meet CSA technical and performance requirements, limited familiarity with the existing body of research and a lack of experience using lower carbon concrete can make them appear risky, especially when it's all too easy to scapegoat innovation for unrelated cost or schedule overruns. Where the technical feasibility is less proven is on the technologies that go beyond lower carbon and approach zero carbon. But there's a massive amount of work being done to ensure they meet or exceed the performance characteristics of conventional concrete. However, industry is reluctant to invest in scaling, testing, and certifying these technologies if there's zero chance they'll be allowed on projects due to falling outside of our prescriptive requirements. Fortunately, these barriers can be overcome by adopting performance-based approaches and improving alignment across jurisdictions. Performance-based approaches, like what's listed in Table 5 of the CSA A23.1 standard, focus on the non-carbon outcomes lower carbon concrete must still achieve, such as strength and durability, instead of dictating which materials can be used and in what proportion. Harmonized, performance-based approaches are a proven way to reduce costs, foster innovation, and improve market certainty. In Canada, provinces have demonstrated this success through decades of collaboration on harmonized building codes. And within newer versions of those codes, approaches to operational energy are also shifting from prescriptive to performance-based. This should be extended to and harmonized with infrastructure projects. And Ceileigh.
Thanks, Jeremy. So moving to our second recommendation. Our second recommendation advises that provinces align with the federal standard on embodied carbon in construction for provincial procurement in order to set measurable benchmarks for infrastructure projects. Coordinated procurement will de-risk investment in lower carbon concrete for Canadian leaders and scale made in Canada innovation. There we go. Okay. In Canada, about 1/3 of concrete is purchased by government. which means that public procurement shapes markets and sets industry expectations about current and future project demand. Thanks, Jeremy. As Canada enters a major nation-building period, government investment in nation-building projects can unlock reliable demand and create economies of scale for emerging lower carbon concrete technologies. Earlier, we heard from Jeremy that Canada's cement and concrete sector is aggressively investing in lower carbon concrete innovation through technologies like SCMs, fuel switching, and carbon capture and storage. As we enter this major nation-building period, coordinated procurement from government can help scale these novel technologies to become market-ready and help Canada cement its position as a global concrete innovator. Public procurement is especially important because of the types of infrastructure that government owns. Horizontal infrastructure like bridges and stormwater systems are almost exclusively owned by governments. These projects also contain a large proportion of concrete relative to other infrastructure types. Aligning procurement across horizontal infrastructure is especially important because of the impact just one or two major horizontal infrastructure projects can have on markets. Thank you, Andy. A framework for coordinated public procurement to support Canadian concrete innovation already exists. The standard for embodied carbon in construction was adopted at the federal level in 2022 to create a consistent approach across projects. This standard calls for a 10% reduction in embodied carbon in ready-mix concrete, which today can be easily achieved using proven technologies like Portland limestone cement, while setting the groundwork for deeper reductions over time. Provinces should voluntarily adopt this standard to send clear demand signals through coordinated procurement. This consistency builds support to scale lower carbon concrete technologies by increasing market confidence for Canadian cement and concrete manufacturers. It also reduces administrative burdens by promoting consistent procurement standards, which can drive down project costs and save money. Moving into our third recommendation, we would advise that provinces introduce incentives to reward private sector projects that reduce embodied carbon. This will support Canadian developers, expedite infrastructure investment, and grow a unified, climate-competitive manufacturing base. These measures may include investment tax credits, application fee rebates, and expedited permitting. Private sector concrete procurement is another important lever for unlocking lower carbon concrete across Canada. Because private sector procurement is made up of a patchwork of different firm and project types, procurement approaches in industry are more inconsistent than in government. In some ways, this fragmentation is actually a strength. It allows some firms to show considerable leadership for aggressively reducing embodied carbon in construction. This leadership is very important. Case studies are critical resources to build industry confidence in novel products like lower carbon concrete. Conversely, the fragmentation of private sector projects does also hurt Canada's cement and concrete industry. In industry interviews, we heard that Canada doesn't need only one or two leaders. We need a coordinated market with consistent expectations for progressively lower carbon concrete. Adopting these materials across industry is difficult because many smaller firms don't have access to in-house materials experts like Jeremy, so they may perceive innovative materials to be costly or risky. With tight timelines and limited resources, many private firms won't look to lower carbon concrete without an incentive. This fragmentation doesn't just hurt Canada's concrete sector, it also drives up project costs and creates inefficiencies that ultimately hurt the bottom line. To create a unified market for Canadian concrete innovation, governments need to point private sector projects towards these new materials. To do so, we suggest that governments introduce incentives to align private sector procurement approaches. Incentives can be financial or non-financial. In the past, federal, and today still as well, federal, provincial, and municipal governments already use several incentives to advance Canada's energy transition that could be applied to lower carbon concrete. These include investment tax credits, development charge rebates, and expedited permitting. Financial incentives could be financed using industrial carbon pricing revenues. Revenue reinvestment is an essential part of carbon pricing policy design, and it has already been used to foster supply-side innovations in the lower carbon concrete sector. To create a unified concrete market, these incentives should encourage private procurement to align with or exceed the federal standard on embodied carbon in construction. Moving towards a unified market with progressive decarbonization standards accelerates adoption at scale, builds industry confidence, and drives down project costs. And with that, I'll pass it over to Jeremy to discuss our fourth recommendation.
Thanks, Ceileigh. So Our fourth recommendation is that a lower carbon concrete toolkit should be introduced to enable workers across the decision-making chain to use lower carbon concrete with confidence. This toolkit should provide a comprehensive collection of resources that will support consistent implementation across the country. So industry interviews highlighted several workforce gaps that must be addressed to support broader adoption of lower carbon concrete. One of the first, confidence and liability concerns remain widespread. Engineers, architects, project clients, and other decision makers raise reasonable concerns about liability when specifying unfamiliar materials. Many practitioners want access to trusted evidence, such as lab tests, case studies, and pilot projects demonstrating its safety and structural integrity before approving lower carbon mixes. However, even when solutions meet CSA technical and performance requirements, finding that evidence can be tricky and takes more time than decision makers have to compile, review, and digest. That, coupled with a lack of personal or local experience using lower carbon mixes, can make them appear risky. This creates hesitation driven by liability concerns and change management challenges rather than a lack of validated data. Second, limited coordination across roles creates barriers. Lower carbon concrete can influence design sequencing, procurement timelines, and on-site scheduling. Interviewees noted, that without early coordination across design teams, it becomes difficult to adapt workflows to accommodate new mixes. The early lock-in effect, where design decisions are fixed before material options are fully explored, was identified as a recurring challenge. This is somewhat mitigated with alternate project delivery methods to the traditional design, bid, build method. Access to expertise varies significantly across organizations too. Larger design and construction firms often employ material specialists in-house. Smaller teams, teams outside of large cities, and under-resourced municipalities do not. This uneven distribution of knowledge means some teams are well equipped to work with lower carbon concrete, while others lack that capacity to evaluate or specify them. And embodied carbon literacy is increasingly important, as performance-based standards and embodied carbon policy requirements, like in Vancouver or the federal standard, become more common. Project teams will need stronger skills in life cycle assessment and basic embodied carbon evaluation. Interviewees stress that a foundational understanding of carbon drivers is needed across roles, not just LCA specialists. This would ensure that teams can collaborate effectively and understand how each choice on each mix affects overall project emissions. While a number of high-quality resources already exist across industry, government, and academia, they're not consolidated or easy to navigate. The Concrete, a pragmatic approach to lowering embodied carbon guide from ZGEF Architects, Fastenep, Elliston, and Lafarge, now Amrise, is a great start. It's focused on BC and deserves to be expanded nationally. An accessible, centralized, and comprehensive toolkit would help, and industry leaders like the could spearhead its development. The toolkit should include performance-based guidance, mixed specification templates, digital carbon budgeting tools, and case studies to help engineers and architects gain knowledge, and a peer learning network should also be included so that well-resourced leaders can share best practices and technical support with smaller teams. In addition to providing information, that toolkit should curate hands-on training by post-secondary institutions or professional associations to demystify the topic and further encourage participation. Finally, the toolkit should be paired with broader outreach to raise general awareness across all construction-related occupations as to what embodied carbon is, why it matters, and how performance-based approaches support the reduction of impacts. Sarah.
Thanks, Jeremy and Ceileigh. That was incredibly inspiring. I know we're all excited about implementing low carbon concrete now, right? We hope this conversation helps move low carbon concrete from discussion into practice. The webinar recording will be posted on our YouTube channel shortly, and the slide deck will be sent out next week. So now it's time for the Q&A portion of the presentation. I'm going to just check out some of the questions here and then figure out who the best person is to answer them. So, all right. So from Forrest, did you review if SCMs are a resource-constrained material in Canada? I hear that using more SCMs on a project doesn't lower global temperatures, but it would, in effect, take away from another project. I'm not sure if I agree with this statement given the impacts of a demand-supply economy. I'd be curious to hear if you thought about this as part of this study. So I think, Jeremy, that might be a you question.
Sure, yeah. So we attempted to consider that. I think one of the things that we were seeing is, yes, they are somewhat a resource-constrained material, but there's also and they're resource-constrained in part because of where they come from. So fly ash generally comes from coal power plants, and slag generally comes from steel blast furnaces, both of which are generally not growing and or being phased out. So yes, if you're working on a project and you specify lower carbon concrete mix that ends up using more SCM, that takes up some of the supply in the market. And if other parts of the market don't care, then that does get recalibrated. Then that does have, I think, limited impact overall. But I think what we're seeing is that demand is outstripping supply. And so that's pushing the kind of the concrete and cement industry to really look at, okay, well, can we find sources of those materials that, haven't been tapped, or, let's look at those other SCMs. Ceileigh, did you have anything you'd like to add?
Okay, that was great. Great answer. Talk about like a two-part question and multiple layered answer. Okay, the next question here is, to what extent are concrete producers, the industry, motivated to reduce emissions ahead of their buyers as high emitters subject to industrial emissions reporting, carbon prices, and requirements? Do you need me to repeat that?
No, I think that's okay. I think through our engagement, as everyone in this call I'm sure knows, the Cement Association of Canada really is a leader in sustainability on the national scale. Obviously, some factors that you've listed here are critical, considering industrial emissions reporting, carbon pricing, and things of that nature, which demonstrate the importance of industrial policy. But I would just underscore that already the industry is doing a really phenomenal job of moving the needle towards net zero. Jeremy, do you have anything to add there?
I don't think so.
Awesome.
Yeah. Okay, great. The questions are coming in fast and furious now here. What would the role be? What would the role of the waste sector, if any? What is the role of the waste sector, if any? Do you see a reuse, recycle aspect of concrete as an option?
Jeremy, do you want to get started on that, or do you want me to?
You start.
Yeah. So I think I'm personally based in Ontario, and we've been seeing a lot of really great advocacy from industry associations for the use of recycled concrete aggregate. So Toronto Area Road Builders Association has been doing some great work harmonizing, there it is again, harmonizing requirements across municipalities and across Ontario. And I can throw it over to Jeremy to kind of provide some additional technical insight.
Yeah, sure. So when we're looking at the emissions of concrete over the life cycle, the bulk of it is upfront. But that doesn't, but a huge amount of the material that's needed and gets transported is aggregate. So that's some of the stuff that the is, I think, more of a topic in Ontario specifically. But one of the other things that the University of Toronto and the Canadian Green Building Council are working on a project that's looking at, well, what is the carbonation potential? So this is basically understanding that once it's been poured, there's science out there that says once the concrete has been poured, the exposed surface area will suck some carbon dioxide out of the air as it cures. But it's based on the exposed surface area. What the U of T and CAGBC team is, the project they're working on is helping to quantify exactly how much that is, not only during its life, but then what's the potential, I believe it's also what's the potential at the end of life. So is there a difference in how much carbon is pulled out of the air by our concrete based on different methods of how it's treated once that building or road has been demolished? And I think that's a really exciting one.
Yeah, that's really interesting. Kind of ties in with this next question here. How pure is the CO2 that is released out of the stack at a cement plant? Just wondering how energy intensive it is to capture, scrub, and purify that CO2.
You want me to take that one, Ceileigh? Okay. So I don't know the ppm of CO2 coming out of cement plant flues, but it is incredibly more concentrated than in the ambient air. And then the other part of it that I think makes it a good solution is, again, part of that CO2 is coming from the combustion of fuels. Some of that CO2 is the output of that chemical reaction when limestone is heated. I believe it is not or I think it will take a significant amount of energy to, not so much to capture, but I think to scrub and purify the CO2. Yes. But that one is, I think, again, if we only have 14 of those plants nationwide, that's not an overly fragmented way to do it.
Yeah. Okay, great. Thank you. So next question here is that in your research, did you consult industry in Alberta? If so, what is the response so far to the innovations suggested here?
I can try to answer that, but if I could, I'll ask who asked that question to just clarify. When you say industry, do you mean like the development and construction industry or the concrete and cement industry, like the producers or the users? But so yes, we did. Primarily what through our interviews, but then we also reviewed a number of documents, either from the Cement Association, from I think Innovation, Science, and Economic Development Canada, and from Emissions Reduction Alberta, that were really did a great job highlighting the pilot projects underway in the province. I think one of them is that's one of the cement plants that is working on bringing in full scale kind of capturing the flue gases. That's one in Edmonton. And then there's also projects on using those magnesium oxides or other things like that.
Thanks,
Ceileigh, did
Jeremy.
you want to add anything?
Okay, thank you. Next question is another concern I have heard is that concrete labor are not familiar with how to best work with higher SCM cements to ensure proper concrete curing, especially for horizontal infrastructure. Have you heard similar concerns, and are you aware of any solutions?
Go ahead, Ceileigh.
No, I was just saying, I think we've definitely heard we've heard curing come up and navigating that. I'm not sure if Jeremy, as a practitioner, has any specific insights and resources that exist.
Well, I think that's the need for that toolkit. That just highlights like that is, I think, a very real concern. And I think higher SCM is again only one of the ways that we can have lower carbon concrete. It's one of the more conventional ways available to us today, but it's not the only one. But I think I am highly confident there's projects across the country that have tried it. And so it's really just about, okay, well, if that's been tried, where has it been tried? And which teams tried it? And so if you have if you're considering it, who can you give a call? Or, have they done an interview being like, oh, well, you needed to spend 20% more time like vibrating it, things like that. I think I don't know the answer to that specifically, but I think that is the proposed solution.
Okay, this question is from Roger. Several questions on design. Reducing unnecessary concrete on beams, concrete companies providing expertise and training, demonstration projects using pre-stressing and post-tensioning.
I
I hope
I
that's clear. I can repeat it.
no, Ceileigh, I mean, I can take a shot at it if you're okay with it. Okay. So um the strategies will definitely vary from buildings to infrastructure. Um and I myself am not the one coming up with these. When I'm looking at it for a project, I'm generally interpreting different design options the engineers or architects have mentioned. So, but one of them, reducing concrete on beams, unnecessary concrete on beams and or columns, is certainly something that has been explored on active projects. Sometimes it's a question of, okay, well, to achieve the same structural integrity, can you use less concrete, but can you use stronger concrete? That's one option. Another one that some of the smart engineers I know have mentioned are the bringing back capitals to our columns. So if you think of kind of like a Greek column, you have the vertical piece and then a part that flanges out almost before it hits the slab. If you're in almost any parkade in Vancouver, you're going to see columns that go right to the bottom of the flat slab. And my understanding is there's likely substantial opportunities for material efficiency to bring those back. Again, I have not analyzed that in detail, but that's comments from structural engineers who I respect. And I think demonstration projects using pre-stressing and post-tensioning, I think that would be one of the things ideally within that kit, calling out which projects are it, because I know, again, just in Vancouver, there are a number of projects that have been using post-tension slabs. But once you're in it, and most of them are more commercial, retail, not residential buildings, once you're in it, you can't tell. It's been covered up by the floor or the ceilings. So I think those are also super exciting ones. And I think it would be like, I think concrete companies providing that expertise and training is great, but it's also a real challenge because under many or kind of the most conventional types of development contracts, they're not brought in until the design is very advanced. And so they're kind of brought in too late for them to really say, well, here's all the things we can do. So there's different types of projects, kind of project contracts that attempt to solve that. There's some kind of design build instead of design bid build, which are sometimes used for schools or hospitals. But I think it's not only those project types that would benefit from bringing those materials expertise in sooner.
Yeah, that's really interesting. Kaylee, did you have anything you wanted to add, or okay? So now I kind of have a broader question, very timely question, in the context of nation building and the speed and scale required to build baby build. Will this fundamentally undermine the ability for government to request LLC through standard procurement processes?
So we would very much suggest otherwise. In fact, we would say as we're entering this major nation building period, and we know that concrete is the most used building material, now would be an opportune time to unlock these innovations that we're seeing across the industry. That's what we were hoping to speak to a little bit in recommendation two, suggesting if we're going to be entering this nation building period, now is the time to support Canadian industry. Jeremy, do you have anything to add to that piece?
Yeah. Yeah, I think it's a fair comment. If we didn't have a standard procurement kind of path already available, if we had to develop that now, yes, that would be tough. But again, the feds have had it since 2022. So it's okay, well, it's there. Can we use it? And can we use it in a harmonized manner? And I think that doesn't undermine government's ability to request it. It really accelerates it. And the other thing too is like this, especially while it's more of a novel topic nationwide, like this isn't a novel topic in Canada. Like the city of Vancouver has been thinking about this for almost a decade with policy since 2017. So a lot of and there's also policy in the Toronto Green Standard dealing with it, not in the base level, but in the more advanced level. So if teams have been trying to get incentives, they've been thinking about this. So nationally, there are engineering teams that have been engaging with this and figuring out how to bring it into the process in a way that doesn't necessarily slow anything down.
Yeah, it's a really exciting opportunity. Thank you for that. So the next question is, what level of technical detail do you find the most useful in embodied carbon toolkits for builders and contractors? High-level comparisons, clear preferred materials lists, or deeper LCA explanations? Jeremy, I think.
So I think it will completely depend on what stage your own project is at. If you are early in the design stage, then maybe you're thinking about changing different structural types. So at that point, how does a concrete building compare to a steel building? Or, one type of concrete compared to another type of concrete building. If you are further into design, then it's questions about, okay, well, how does one material compare to another, maybe for your insulation? So at that point, it's on a per meter basis or a per cubic meter, per square meter of wall, or per cubic meter for kind of more monolithic elements. It's how do these things compare to each other, assuming that they're one-to-one, right? Because you generally will need more concrete than you will steel to build 1 square meter of floor. And then the final one is probably what free tools like EC3 or the North American Material Baselines report from a group out of Washington, where they've looked at, okay, so for this one material category, what's the average intensity per cubic meter? But then we'll also, who has, which suppliers have a lower carbon version of that product? And sometimes it comes at a cost premium, sometimes it doesn't, which is really exciting.
I'd also suggest, and Jeremy, let me know your thoughts on this. In terms of a preferred materials list, I think we would potentially err away of that, just in terms of prescriptive lists locking out innovation. We want to ensure that we're really taking a technology agnostic approach here and that we're opening any market ready competitive solution.
Yeah, totally. You're right. Thanks, Ceileigh. Yeah, the key thing of those data points is generally they're not focused on the technology used to produce those materials, but what is the GWP, so the global warming potential per X amount of that component. Sarah.
Yeah, okay, thanks. One more question here. From a municipal perspective, what level of detail actually helps reduce liability concerns for builders and inspectors without overwhelming them? How do you decide what belongs in a public-facing toolkit versus a technical back-end guidance?
Do you want to try that one, Ceileigh? Do you want me to try it?
I think you have some insight in terms of using the materials, so you go ahead.
Okay. I think it's tricky to know exactly which level of detail actually helps. And I think that's where those peer learning networks are especially valuable. That can sometimes help when you have an exceptionally long and technical backend piece of guidance, that will help us all collectively navigate and make sense of it quickly. I think the tricky part is the public-facing toolkit is still generally probably pretty technical. So again, it's not so much written for the layperson, but it's written for the average engineer or the average procurement official. Anything to add, Ceileigh?
No, I would reinforce the importance of the peer learning network. I know, like within Ontario specifically, Toronto, Richmond Hill, like we have some municipalities that are really leaders. And I think one of the first big hurdles to get over is not necessarily a technical challenge, but a cultural Yeah, and I think peer learning networks and things of that nature will be very.
Okay, thanks, Ceileigh. Question from Andy. When we're thinking about getting low carbon concrete into common use, should we be targeting the people spending the money on massive projects, either privately or in government? What incentivizes that group with big wallets and grand plans?
Yes, that is definitely of interest. I would say, as Jeremy and I have discussed, the federal standard is very appropriate in terms of potential extending it to other public procurement approaches. So 10% reduction in ready mix concrete. We would suggest that that is appropriate for adoption across provinces. And then in terms of engaging with the private sector, as Jeremy shared, we already have a lot of leaders, but bringing everyone else in line with that this federal standard as well, calling out some of those, we're reaching back and discussing the financial and the non-financial incentives we've discussed historically. So things like investment tax credits may have some applications here, obviously structured a little bit differently. Jeremy, I know when we were discussing this, expedited permitting is also another non-financial incentive that came up. And I think Vancouver uses that already for like energy efficiency and affordable housing. Okay.
I
believe
I
so.
think so, but I also am pretty sure there's some members of the audience who know the exact answer, so I won't.
Yes. No, we won't speak on it. Yeah.
So I'm not going to be too specific because I will probably get it a little bit wrong. Um,
Yeah.
but I think one of the things to add too is the federal standard does not apply to everything. It has a limit within it. I think it's projects that either order over 100 cubic meters of concrete or have overall budgets over $5 million. I believe it might be 1 million, but basically it's not intended to apply to the smallest sidewalk repair, but it's okay if we're building a high-speed rail network, maybe the concrete being used on that, like that project alone would probably will take up a year or two's worth of an order book.
Yeah, that's a great example. I love that, tying it into those big nation building projects. Okay, so I don't see any more questions in the Q&A here.
Sarah, I'm just going to jump in briefly. I've seen a couple people
Okay.
discuss getting in contact with us afterwards. I've taken down your names and will get your contact information from the registration list. Sorry, so go ahead, Sarah.
Thanks for seeing those in the chat. So if we don't have any more questions, I think we'll close for today a bit early so people can get some time back in their calendars. So we all need that. Thanks again to our speakers and participants, really engaged, who brought so much expertise to the session. And have a wonderful rest of your day.